Okay, so today we're going to look at graphing quadratic functions, and we're going to look at all the different features and locations and things you need to know about graphing quadratics. So the first thing that's important today is to remember how to do these graphs. So do them on Desmos. You can type in the equation on desmos.com or put it in on your calculator, whichever you prefer, and hit graph, and should be what it looks like. So remember, our y-axis is the up and down one, and our x-axis is the horizontal one. So when we draw a graph, we should get a U-shaped graph looking something like what I've sketched here. And we know that it's going to be upwards because of the positive 2. Right? In our equation, we have a positive 2, so we know it's going to be upwards, and we know it's going to be a little bit skinnier based on what we learned the other day. So now the first step is, let's find all the key features to this graph. So the first one is Y-Intercept. So our Y-Intercept is where it crosses the Y-axis. So in this case, off your Desmos or your calculator, you can trace over, and you can see that that point is at 0, -3. So at the coordinate 0, -3, that's where it's crossing our Y-axis. So that is what we call our Y-Intercept. The X-Intercepts are located where it crosses the x-axis. And in this case, you can see it crosses the x-axis in 2 spots. So the one on the left, if we scroll over on our graph, we get -3, 0, and the one on the right, we get positive. We get positive 1/2 and 0. And those two are our x-intercepts. So in this case, 2 different x-intercepts because it crosses in 2 different places. Just a quick thing on x-intercepts, depending on the graph, quite often we get 2 like we have here, or even if our graph was upside down, you can see we'd have 2 different x-intercepts. Okay, so quite often you're going to get 2, but it's also possible to get either 1 or 0, and it just depends on how the graph is going to look like. So for example, if we had a graph that looked something like that, you can see it only touches it in 1 spot. So in that case, we'd have 1 x-intercept. Or it's possible that we get a graph that never touches the x-axis. So in this case, we have 0. Okay, so 0 x-intercepts. This one has 1x. Or like the one I have on the left here is 2. So quite often you're going to get 2 x-intercepts, but just be aware that sometimes you might get 0 or 1, depending on the question. Okay, so back to our original graph, so we've got our x-intercepts and y-intercepts figured out. The other key point on one of these graphs is the vertex. And the vertex is the point that the U-shape goes to. So in this case, it would be the bottom of the U, the tip, or if the graph was upside down, it would be the peak. Okay, so we call it the vertex as sort of being the maximum or the minimum. So in this case, let's locate the vertex. It's going to be down here at the bottom, and we're going to use our calculator or the program to find that one. In this case, it's going to be at -1.25 and -6.125. Okay, so there's our 4 key things. So 2 x-intercepts, y-intercept, and our vertex. Okay, so now let's go through a little bit more analysis with this graph. So we have our key points in the graph already labeled. So now what we want to do is we want to go through some of the other terminology that you have to be aware of. So the first one is the axis of symmetry. And the axis of symmetry, just kind of like it sounds, it's asking what would the line be that cuts this graph in half. So if you look at the graph, right down the center of it vertically should be the axis of symmetry. That's going to be what cuts this graph in half. So all of the points are equally spaced on either side. Okay, so if you look at the 2 x-intercepts, we have -3, we have positive 1/2, so halfway in between those should be where the x-axis of symmetry is. Okay, so if we actually do that, if you go -3 plus 1/2, that gives you -2.5, and we just average those. We figure out what's halfway in between, divide that by 2, you get -1.25. Okay, so you can do it that way. You can take any points and just average the two or figure out what's in the middle of them. Or the easier way is look at your vertex location, and you can see the first value of the vertex, the x-coordinate, is going to be your axis of symmetry. Okay, so all we have to do is by looking at the vertex, just say our axis of symmetry is x equal negative 1.25. Okay, so that's the easiest way to do that one. It's your x-coordinate of your vertex. But we could do any two coordinates on the graph that are across from each other, figure out what's halfway in between. The other key feature for a graph that we have to be aware of is the domain. And for any graph, the domain is always what are all the possible x values. So because our graph goes on and on forever, it's going to be this U-shape, but it's going to go on and on forever upwards. Every possible x value will be on that graph. So it doesn't matter where I trace it. So you could do this on your calculator, and you could trace your coordinate up here or up there, or you could keep on going on and on forever. There's going to be every possible negative x coordinate and every possible positive x coordinate. So the way we were going to write that is we're going to say x can be any real number. So it's a funny little E shape. It just means a subset. So x is a member or a subset of any real number. The key thing for domain to remember is for quadratic graphs, it's always going to be that. There's never going to be an x value that doesn't show up on the graph. Doesn't matter how skinny or how wide or how tall, you're always going to get every possible x value. The last one we got to do is the range. And the range is figuring out all the possible y values that are on the graph. So domain was x values, range is the y values. So in this case, all of our possible y values are going to depend on which way the graph goes up or down. So in this case, it's opening up. So you can see in the positive direction, we go on and on forever upwards, but in the negative direction, we go down until we get to the vertex. We never go below the vertex. So our range will be from the vertex and larger. So we always write it as greater than or equal to. And in this case, our second value of the vertex will be your range. So we want it, all of our numbers are bigger than negative 6.125. We never get any values less than that. For this graph, that's the minimum. It's never going to go anything lower than that. Okay, so let's try a different equation. So let's pick a new one, just to make sure you're clear on this. So if we do, let's do a graph of y equals negative 0.5 x squared. So let's type that in on Desmos, 0.5 x squared minus 3x. And let's go minus 2 this time. Okay, so there's our equation. Let's sketch that out. So on your calculator, let's draw the graph. So our graph is going to look a little bit different this time. It's upside down. Our graph looks something like that. Okay, so once again, we can find all of our key points. So the first one, let's do the vertex this time first. It doesn't matter which order you do them in. So our vertex is at negative 3 and 2.5. And let's do our X-Intercepts. Our X-Intercepts are at, these ones are decimals in this case, 5.236. And the next one is at negative 0.764. And let's do our Y-Intercept. So our Y-Intercept is down here, and it is going to be 0, negative 2. Okay, so we have all of our 4 key points in this case. We see it's opening downwards, and that's it. So we have all of our key stuff, so let's go through the rest of them again. So our axis of symmetry is going to be the line that cuts it in half, right? So that's the line that goes down the middle. So in this case, remember it's your x coordinate of your vertex. So we'd say it's x equals negative 3. That's going to be where it cuts it in half. And if you average halfway between negative 5.23 and negative 0.764, add those, divide by 2, you will get negative 3. Okay, our domain. Remember, domain was all of our possible x values. Because this graph goes on and on forever in both directions, we're always going to get every possible real number. And our last one, the range, is in this case our graph has a maximum. We're at a peak of 2.5. So our range will be that second coordinate, but now instead of being greater than 2.5, because the graph is upside down, it's going to be less than or equal to 2.5. And that's it for the different features of the graph. So X-intercepts, Y-intercepts, vertex, domain and range, and that is all.